Okay, today we're going to do section 3.5, solving equations with the variable on each side. So the first thing I want you to do is to copy down these steps for solving general equations. And these are suggestions. They're not going to work for every equation, but for the ones we're working on today, these will do just fine. So first, you're going to simplify each side, if necessary, by using the distributive property. The if necessary is there because sometimes a side is already simplified and sometimes you need to do some work with it. So simplify each side, if necessary, by using the distributive property and or combining like terms. The second step is to use the addition and or subtraction property, you can use either, of equality to put all the variable terms on one side of the equation and the constants on the other side. And we'll talk a little bit about that and how that's going to work. But jot the steps down and then we'll work on them together. The third step is to combine like terms using the distributive property. And by that we mean that 3x plus 2x is 3 plus 2 times x, or 5x. So that's what we mean by combining like terms. You don't need to show this in between step, but know that when we go from 3x plus 2x to get 5x, we are using the distributive property. Solve for the variable using multiplication and or division property of equality. And the last step, that's it, because then we will have then solved for the variable. That's our last step. So make sure you've paused the video and written all that down. All right, so let's look at this together and see what we can come up with for our steps. So the first step, remember, was to simplify each side if necessary. But when I look at this, the left side is simplified. I cannot combine these two because they are already, they're unlike terms. And the right side is simplified. Now the entire equation is not, but each side individually is as simplified as I can get it. So I'm going to go on to step 2, which is to use addition or subtraction property to put all the variable terms on one side and all the constants on the other. So I'm going to work the variable terms first. So to get the variable terms onto one side, I'm going to subtract 8p from the right and from the left, and then I will get negative 2 plus 2p equals 8p minus 8p is 0, so I just have my negative 8 left. Then I'm going to move the constants to the other side by adding 2. So I get 2p equals negative 6. So now I've gotten all the variables on the left and the constants on the right. The last step is to look and see if I need to combine any terms. I do not. And finally, I'm going to use division or multiplication. In this case, since it's 2 times p, I'm going to divide by 2 to get my final solution. I always want to take the time to check my work. So I'm going to go back, to the original equation, negative 2 plus 10p equals 8p minus 8. And I'm going to substitute in place of p my negative 3. And I'm going to get negative 2 plus negative 30 equals negative 24 minus 8. And both sides equal negative 32. So it does check. All right, let's try another one. All right, now in this case, the left side does need simplification. I can distribute, and I will get 8x minus 32. The right side also needs some simplification because I can combine terms here and get 7x plus 10. Again, I'm going to move my variables to the left. Negative 7x, negative 7x. That will give me 1x minus 32 equals 10. I'm now going to add my 32 to both sides. And in this case, I'm finished because I have x equals 42. Again, a check of my work. 4 times 2 times 42, substituting in place of the x in the original equation, my 42 minus 8 equals 3 times 42 plus 10 plus 4 times 42. So this is going to be 4 times 84 minus 8 equals 3 times 42 is 126 plus 10, and 4 times 42 is 168. Continuing, 4 times 76 equals, I'm going to go ahead and add these together. It comes to 304, and 4 times 76 is also 304. And I wouldn't give you numbers this big without a calculator. I would expect you to be able to do it, but it's time consuming, so we would stick to a little simpler values. Okay, let's look at another one. So the left side looks good to me, 2q plus 5. I can't simplify the left side. The right side needs a little work. 2q plus 5, I'm going to distribute, equals 5q minus 35 minus 3q. Still not quite done simplifying on the right-hand side. Notice the left-hand side hasn't changed. So combining my like terms, 5q minus 3q is 2q minus 35. Now I'm going to move my constants to the left like I've been doing. Subtract 2q from both sides, and I get 5 equals negative 35. Wonder if I did something wrong. Let's take a look. Here's what's happened. We now have a situation where it is impossible to make the left side equal the right side. This is never true. I haven't made any math mistakes, but 5 cannot equal. It does not equal negative 35. So let's look back to this line before my variable disappeared. If I pick any number for q and plug it into this line, 2 times q on the left and 2 times q on the right is going to give me the same value. If I have a value and I add 5 to it, can it ever equal the same value, minus 35? No. So this equation has no solution. So it is not possible for any value of x or q to make this statement true. I've gotten to the point where I never, ever, ever can make this true. So therefore, no matter what value of q I put in up here, it will not be true. So no solution. Let's try one more. All right, the left side needs some work. I'm going to distribute 3x plus 3 minus 5. The right side is okay. Combining my like terms, I get 3x minus 2 equals 3x minus 2. Wait a minute. That looks funny. That's identical. That looks like the reflexive property. A thing that equals itself. Let's keep going a little bit and see what happens. If I subtract 3x from both sides, I'll get negative 2 equals negative 2. Negative 2 equals negative 2. This is always true. In other words, if I go back to this line, no matter what value I put in for x, that statement will always be true. If I plug in 7 for x, I'll have 21 minus 2 equals 21 minus 2. If I put in 3 equals x, I'll have 7, or 9 minus 2 equals 9 minus 2. No matter what I do, this is going to be true. So the solution for this is all values. Or we can say that there are infinite solutions. So the last two cases were kind of special cases. If you solve an equation and end up with a statement that is not true, as long as you didn't make a math mistake up here somewhere in your work, there is no solution. And if you come up with a statement that is always true, then your solution is all values, or you can put infinite solutions. So let's take a look at that. 3 different cases. If you have a solution in the form of a single variable equal to a number, like we got earlier when we had x equals 42, then we know that the equation is true for one solution only, the solution that we came up with. If the solution comes in the form of a number that is equal to itself, like we had -2 equals -2, then the equation is always true and there are infinite solutions. And if we end up in a solution in the form of a number that cannot equal a different number, in other words 5 equals -35, but that's not true, then the equation is never true and there are no solutions. So we'll do a little bit more practice on this in class, but that's it for the video.